Happy Thursday, guys! As promised, I am going to be teaching you at least part of the 2.5 notes today via this video. So anyway, I hope you guys are all having a good day. So lesson 2.5 is all about basic differentiation rules, which is kind of the shortcuts to taking the derivative, because in the past we have seen differentiation or taking a derivative by using a limit, the difference quotient, right? The limit as h approaches 0 of f of x plus h minus f of x over x plus h minus x. So these rules are basically the shortcut to that. And you'll probably remember the most basic power rule from last year when we get to it here. But all right, let's go ahead and get started. So basic differentiation rules, the constant rule. The derivative of a constant function is 0. So basically what that means is, remember that a derivative is a slope. If you have a horizontal line, the slope of that line is always 0. Thus, the derivative of a constant or the derivative of a horizontal line is 0. So down here, these 4 examples, these are all constants. So when we take the derivative of any of these, if you have y equals -4, that's a constant, y prime is going to be 0. If we have s of t equals 45, that's a constant, s prime of t is going to be 0. F of x equals 0, 0 is a constant. The horizontal line y equals 0 is the x-axis. So f prime of x, oops, I meant x here, is 0. And y equals k pi over 2. Well, k is just some multiple of pi over 2, while any multiple of pi over 2 is just a constant. So y prime is 0. That easy. Okay? Now, when we have a single variable, meaning just an x to the first power or t to the first power, that is a line with a slope, but it's a linear function. The slope of that line is always constant. So the derivative of that will always be 1. So f prime of x here is 1. F prime of t has a power of 1 here, so the derivative is 1. And x prime of t is 1, since these are all degree 1 functions. Okay? So also very basic. Now these are all just special cases of this general rule called the power rule, which says if n is a rational number, then the function x to the nth power is differentiable, and the derivative of x to the n is, you take this power, you bring it in front as the coefficient. If there already is a coefficient there, you have to multiply it, and then you drop the power by 1. You probably remember from last year us talking about the derivative of a function is always 1 degree less. That's where that comes from. You drop the power by 1. So example 3 says use the power rule to find derivatives. So here, if y is x squared, then y prime is going to be, the 2 comes in front, x to the first. Drop the power by 1. Here, f prime is going to be 4x to the third. Coefficient, or power comes in front as a coefficient, and then you drop your power by 1. Okay, now first you need to sometimes rewrite the function in terms of an exponent. So this is going to be x to the 1/2 power. Remember, square root is 1/2 power. So that means y prime is going to be 1/2 x to the, now 1/2 minus 1. We're going to be doing a lot of subtracting fractions. So remember, you got to get common denominators. 1/2 minus 1 is easy to see as -1/2. But you could also do 1/2 minus 2/2, and then 1 minus 2 is -1. So we get -1/2. And so we want to change this back to a positive exponent. So the x to the negative 1/2 power is going to go in the bottom. So we're going to get 2x to the positive 1/2. And then sometimes my answer keys will switch this back into square root of x. Either of these answers is acceptable. Just know for multiple choice purposes, you have to be able to recognize equivalent forms. Okay? Now, over here, for D, g of x equals 1 over x. To turn that into an exponent, since it's in the bottom, we can bring it to the top by making this x to the negative first. So that makes this easier to see. When that exponent comes in front, this is negative 1x. Drop your power by 1, that becomes to the negative 2nd power. So now, when I go to simplify this, I have negative 1 over x squared is my derivative. Okay? Basic power rule. All right, let's do some more practice with this. First thing we have to do here, let's turn this into x to the negative 2nd power. Because now f prime of x, or the derivative of x, is going to be negative 2. Exponent goes in front as the coefficient. X to the, drop it by 1, negative 3rd power. And then let's rewrite this now without the negative exponent. So put the x to the 3rd in the bottom to become positive. All right. Now we have in f 1 over x to the 2/3. So let's switch that to x to the negative 2/3. So y prime is going to be, exponent goes in front, so negative 2/3. X to the, a negative 2/3 minus 1. When I subtract 1, I'm actually going to subtract 3/3. And I'm going to do this a lot in this lesson. So we get negative 5/3 is the exponent. That's just kind of some scratch work. And then we can rewrite this. Negative 2 over 3x to the positive 5/3. Okay? All right, now we have the sum. So this basically wrapping up the general power rule. The derivative of the term ax to the nth, where a and n are real numbers, is a times n. Basically what this is just saying is if you already had a coefficient here, when you bring your exponent in front to take the derivative, you multiply that exponent by the existing coefficient to get your new coefficient, and then still drop your power by 1. So your steps here say multiply the coefficient by the variable's exponent. I'm not sure that these steps are in your notes, but these are just good steps to look at here. If no coefficient is stated, in other words, the coefficient equals 1, the exponent becomes the new coefficient. Subtract 1 from the exponent. Okay? All right, let's take a look at some more examples. So here you have y equals 3x squared. So y prime, 2 comes in front, multiplies by the 3, so we get 6x, and then drop your power by 1 would be to the first. Here, s prime of t, 3 comes in front, so you get negative 15t, drop your power by 1, so squared. Oops, I was just going to try and move that up. Never mind. Okay, next one. Let me erase this real quick. We have 6 square root of x. So again, what we're going to quickly do is rewrite this as 6x to the 1/2. So now for y prime, 1/2 multiplies in front to get 3, because 1/2 times 6 is 3, x to the negative 1/2, which we're going to rewrite as 3 over x to the positive 1/2, which you could, again, rewrite as 3 over square root of x. Either of these two would be just fine. rewrite d real quickly by bringing that up, because now we can use the power rule to take the derivative. Negative 2 times 3 is negative 6, x to the negative third, which can be simplified to negative 6 over x to the third. Okay. Now e, this is a two-step quickly simplifying before taking the derivative. First of all, changing that square root of x to the 1/2 power, and then bringing it all up to the top. So this would be for x to the negative 1/2, so that now we can use the power rule. So f prime of x is going to be, now negative 1/2, oops, switch back to the eraser, hold on. Negative 1/2 now is going to get multiplied by the 4, so we get negative 2x. Negative 1/2 minus 1 or 2/2 is going to be negative 3/2. So this is going to be to the negative 3/2 power, which then we can rewrite this as negative 2 over x to the positive 3/2 power. Okay. So now we have to do the same thing over here. First, we have to rewrite this, getting rid of the root. So now x to the 4th, the cubic root of that would be x to the 4th to the 1/3 power. And then when you have power to a power, you multiply. So this will be x to the 4/3, because 4 times 1/3 is 4/3. Then we need to bring that up to the numerator. So we get negative 8x to the negative 4/3. So now we can take the derivative. So y prime equals negative 4/3 times negative 8. Now, when you multiply fractions, you just multiply straight across. So you get positive 32/3. And then negative 4/3 minus 1 would be minus 3/3. So you get negative 7/3. Which now we'll rewrite as 32 over 3x to the positive 7/3. And this is all just my little scratch work down at the bottom. Okay. All right, sum and difference rules means that if you're taking the derivative of a polynomial or like an expression that has multiple terms, you just do the power rule to each term individually. So when you're adding and subtracting terms, you can take the derivative of each term using the power rule separately. Okay, so looking at this one, we have a polynomial, a cubic function, and so f prime, very simple here. Just power rule all the way through. So 3 comes in front, x to the 2nd, drop the power by 1. Minus 2 comes in front, times 5 is 10, x to the 1st. Plus, this technically has a power of 1. 2 times 1 is 2. Now x to the 0 will cancel that out because x to the 0 is a 1. And then remember, the derivative of a constant is 0. Now I'm not going to write it all out like this every time, but I just want you to see where this comes from. So we get 3x squared minus 10x plus 2, because x to the 0 is 1. And then minus 0 is gone. So this is the derivative. Okay? All right, here, 5 times 2/5. These will cancel out. So you get 2x to the 4th plus 4 comes in front, x to the 3rd. plus 6x to the first, and then the derivative here will be 0. So that's it for that one. Okay? All right, first thing we need to do here is rewrite these using exponents. So I'm just going to write up here, this is equal to x to the 1/3 plus 5x to the 1/2. And now I'm going to use my power rules. So g prime of x is 1/3 x to the, now 1/3 minus 3/3 will be negative 2/3 plus 1/2 times 5 is 5/2. X to the 1/2 minus 1 is negative 1/2. And now I'm going to get rid of my negative exponents. So I'm going to get 1 over 3 x to the 2/3 plus 5 over 2x to the 1/2. And again, you can change that x to the 1/2 back to a square root if you want. I'm not going to. Okay? All right, y, everything is almost good down here. 5x to the 3/2, we'll do the power rule on that, minus 6x to the 5/3, we'll do the power rule on that. But now I need to change 4 over x to be 4x to the negative 1, so that I can do the power rule on that part. So I get y prime equals 3/2 times 5 will be 15/2. X to the 3/2 minus 2/2 will be 1/2. Then we'll have minus 5/3 times 6 will be 30/3, which is 10. X to the 5/3 minus 3/3 will be 2/3. Now, this is technically going to be plus negative 4. When I multiply that negative 1 times the 4, so I'm just going to go right to minus 4 x to the negative 2nd power. So, of course, I'm going to want to rewrite this now. You could rewrite this as 15/2 square root of x minus 10x to the 2/3. That's a positive exponent, so that doesn't have to change. Then we get minus 4 over x squared, turn that back to a positive exponent. Okay? And then the last two that we'll do for today. First thing we got to do is fix this up. So we get 3x squared, that's good, minus 4x to the negative 2nd power, bring that up, plus 2x to the 1/2. All right, now we can do power rule. So h prime of x is going to be 6x. Now when I multiply this negative 2 times this negative 4, this is going to turn to plus 8x to the negative 3rd plus 1/2 times 2 is 1x. 1/2 minus 1 is to the negative 1/2 power. So rewriting this, h prime of x, we get 6x plus 8 over x cubed plus 1 over x to the 1/2, or 1 over the square root of x. Okay. And last but not least, part F here. First thing I got to do is get rid of this fraction. So I'm going to divide all of these terms by x. So when I divide the first term by x, this becomes 8x squared. When I divide the second term by x, this becomes plus 4x. And since I can't technically divide negative 3 by x, this would be minus 3 over x, which is minus 3x to the negative first. And now I can take the derivative using power rule. So 16x plus 4. Now negative 1 times negative 3 will be plus 3x to the negative second. And rewrite that. We get 16x plus 4 plus 3 over x squared. Okay. All right, I'm going to stop there for today. And tomorrow we will go through the notes together for the rest of this lesson, which is the derivative of sine, cosine, and tangent, and then derivative of exponentials and natural logs, so exponentials and logs. But you can start working on the assignment, ones that are strictly non-transcendental, I guess would be the word, so more algebraic like this. You have to rewrite a bunch of your functions first, like we had been doing, and then apply power rule to take the derivative. All right? So start working on the assignments, daily quizzes for 2.5. I'll be back tomorrow with your quizzes graded and to finish going through these notes. And we'll see you then. All right, guys, have a good rest of your day.